Hey, geometry class. Welcome back after that 15 minutes that you're probably going to tell your grandchildren about being the best 15 minutes of geometry in your life. Hey, so the next part of this lecture is section 4.7 and 4.9 in your notes. And 4.7 has everything to do with corresponding parts of congruent triangles being congruent, which means if you have two triangles that are congruent, right? Then you can establish that any one part, any corresponding part of one triangle is the same in the other. So how this works is you are going to use those other postulates and theorems, side, 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 side angle, side, etc., to prove triangles are congruent. And then once you know that they're congruent, you use CPCTC to say that the parts that you didn't prove have to be congruent too. And we're going to be doing a lab on this Monday in class. So let's take a look at a problem. It says a landscape architect sets out triangles shown in the figure to find the distance across a pond, because you couldn't actually throw a measuring tape across the pond, right? So what is JK? What is this distance? Well, what we need to recognize is that 19 and 19, okay, those corresponding sides are congruent, and 30 and 30, those corresponding sides are congruent. Well, how can we prove that these two triangles are congruent? And I hear Kylie just screaming out right now. She's like, Mr. Rising, those are vertical angles. Those vertical angles have to be congruent. And she's absolutely right, because now you can set up side, angle, side. Side, angle, side congruence. So once you know you have side, angle, side congruence, then this side JK has to be 41 feet. Now, here we're going to do a proof using CPCTC. And let's just start off. It says PR bisects QPS. So again, QPS, it's going to bisect this, and QRS. Okay, well, statements on the left, reasons on the right. It says PR bisects the angles, and that's given. What does it mean that it bisects those angles? Well, simply put, it means that this angle is congruent to this one, and this angle is congruent to this one. And when I say this angle, of course, I'm referring to angles QPR congruent to SPR, and QRP congruent to SRP. And that is because of the definition of an angle bisector. Now, again, how would you prove that these two triangles are congruent? You've got two angles congruent. It would be great if we could get a side. Anybody know a side? Well, yeah, that's Josh, you're right. I hear you telling me that right there. You're like, well, Mr. Rising, PR is congruent to PR by the reflexive property. All right, so we'll put a little congruent mark there, which means now I've got congruent triangles. Triangle RPQ is congruent to triangle RPS. And again, the order of the vertices matter. You have to give them in order, as long as it's the same across both figures, by angle, side, angle. Oh, sweet. Well, now that I know that, then I can conclude that PQ, segment PQ over here, is congruent to PS because of CPCTC. That's how it looks. Now, on this problem, I'm going to go to the board. I'm going to kind of shout out. When you have to prove triangles are congruent on a coordinate plane, the way to do this is to show side, side, side congruence. Well, how do you know sides are congruent? Sides are congruent if they have the same length. So we're talking distance formula here. So we're going for side, side, side. So let's try this problem. J, -1, -2. -1, -2. All right, here's J. K, 2, -1 to -1. And L, -2, 0. Oh. -2, 0. All right, now I'm comparing that to R, which is at 2, 3, 2, 3. S, which is at 5, 2. 1, 2, 3, 4, 5, up 2. And T, which is at 1, 1. Now, please do your best at lining these up nice and neat. I'm going to show you a really quick way to do the distance formula. All right, so what do you guys think? Are these triangles congruent or not? Well, here's how you do it. Make right triangles for each of your sides. And you can see my drawing's a little bit off. Now actually this is a pretty good way to do it, and I'll show you a quick way to determine the length of each one of those hypotenuses. Come on in, Jasmine, I'm just doing a problem on the board. So what we need to do is the side here is 1, and 1 squared is 1. Okay? This side here is up 2. 2 squared is 4. In order to find c squared, you add a squared plus b squared equals c squared. So really what I'm saying is a squared is 1, b squared is 4, c squared, right, if I add them together, is 5. 5 equals c squared, so therefore c equals the square root of 5. What we need to do is do this Pythagorean theorem for each side of both triangles, and that's a way to prove that the lengths are indeed the same. Okay, so to conclude, the length LJ equals the square root of 5. The next one here, I'm going to just try to make it as clean as possible. Again, I'm going up 1 from J to K. So this is really 1 squared, which is just 1. And this is 1, 2, 3, 1, 2, 3. 3 squared is 9. I add these two values together and take the square root. So from J to K, this is the square root of 10. And again, I'm doing the same problem, Pythagorean theorem. I square A, I'm like pointing at the screen like you can see it. Square A, add it to b squared, add those together, and then take the square root of both sides in order to solve for c, the hypotenuse. So the last one here, from k to L, I'm trying to find LK or KL. Of course, it's going to be the square root of something. And again, I go up 1. I go up 1, and then 1 squared, of course, is 1. And then 1, 2, 3, 4. Do that right? Looks pretty good. 4. 4 squared. So 1 squared is 1, plus 4 squared is 16. So this is equal to 17. So this is the square root of 17. Now, if these measurements, if the length of RS, ST, and TR are exactly the same, then I have congruent triangles. So let's do it real quick. Right here, I'm going 1, 2, 3. 3 squared is 9. I'm going 1. 1 squared is 1. I'm going 1. 1 squared is 1. Here I've got 1, 2, 3, 4. 4 squared is 16. And this is going to be up 1, 2. 2 squared is 4. All right, which means, oh my gosh, now my writing's looking really scary, but that's what it would look like in class anyways. From R to T is, actually this is 1 as well. 1 squared is 1. From R to T, RT equals the square root of 5. From S to R, it's the square root of 10. And from S to T, that is the square root of 17. Now I have shown by side, 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 that those two triangles are congruent. This is a lengthy problem. I recognize that. It takes a little bit of time, but that is the process. Okay, so now we're going to move on to isosceles triangles and equilateral triangles. And so an isosceles triangle has at least two congruent sides. It could have three, and that would make it equilateral. The vertex angle, of course, is the top, right? And it's formed by legs. So these are legs. The base is the bottom opposite the vertex angle, and these are called base angles. So 1 and 2 are base angles, 3 is the vertex angle. So you've got these theorems in your book, and of course isosceles triangle theorem says if the sides are congruent, the base angles are congruent. The converse of that says if base angles are congruent, then the sides are congruent. So what you have to do, you get these pictures and problems, and it says, hey, the length of yx is 20 feet. All right, this is 20 feet. Explain why the length of yz is the same. And if this angle right here is 140 degrees, well, what does that mean? Well, because 140 is an exterior angle, 140 equals 40 plus this angle right here. And you're screaming out saying, well, Mr. Reisman, that obviously has to be 100. Okay, well, if this angle is 100, that means this angle here also has to be 40 degrees. So what you're saying is the reason that YZ has to be the same as XY is because the converse of the isosceles triangle theorem, right? The base angles are the same, therefore the sides are the same. In this problem here, again, if this top angle is 22, and I know these two angles have to be the same, 22 plus 2, let's just use B for base angle, equals 180. Well, let's subtract 22 from both sides. So that would be 158 equals 2B. Divide by 2. Divide by 2. And that goes B equals 79 degrees. So my base angle here is 79 degrees. I just have a couple more slides and just a couple more minutes. The last part we need to talk about are these equilateral and equiangular corollaries. And again, they're a special kind of isosceles triangle because all sides are the same. If all sides are the same, then all angles are the same. It's kind of like the converse of that equiangular triangle. If all angles are the same, then all sides are the same. And this is what it can look like. When you get a diagram, it says, hey, all the angles are congruent. You need to say to yourself, well, shoot, Mr. Rising, all the sides have to be congruent. If that's true, it says find the value of JL. I'm not leaving until I know what JL is. I need to set it up. 2t plus 1 equals 4t minus 8. Let's get all the t's together. So I've got 2t minus 8 equals 1. I'm going to add 8 to both sides. And then I've got 2t equals 9. Divide by 2. And t equals 4.5. Now I'm not done. I need to plug this back in. So I'm just going to plug it in right here. 2 times 4.5 plus 1. This is 9 plus 1 is 10. That's how you do that. In my last minute, I just want to say this is not my favorite way to show you new concepts and whatnot, but it is important that we can sometimes work asynchronously and you can see things on your own. So after this lecture, please work on your Khan Academy. 30% is due by November 20th, 40% by December 21st. I will see you guys on either Monday or Tuesday. This is somebody famous, and that might be a extra credit question on your quiz next week.